Hello children, good morning. Welcome to today's session. In the last class we have discussed regarding is matter around us pure in that homogeneous mixtures. Today we shall learn about heterogeneous mixtures. Homogeneous mixtures, the best example is solutions, right? Now we shall learn about suspensions and colloids today. What are suspensions? Suspensions are nothing but heterogeneous mixtures where the particles are not uniformly distributed throughout the medium, or we can say here the particles are not dissolved in the liquid, and in suspensions the particles can be seen through our naked eyes. How it can be seen through our naked eyes? Because particles size, it depends upon the size of the particles, where the size of the particle is more than 100 nanometer. In solutions, that is in homogeneous mixture, the size of the particle is less than 1 nanometer, but here it is more than 100 nanometer. That's why we can see the particles in suspensions. And in suspensions we can filter the particles in the suspension using simple filter paper, but solutions we cannot. See, example for solution is salt and water. After dissolving the salt in water, we cannot filter the salt using filter paper. It is highly impossible because salt size is very small. After dissolving in water, it cannot pass through the filter paper. But mud and water, it's a suspension. We can filter the mud using filter paper because particle size are more here, and that's why here we can say the suspensions are unstable. Why it is unstable? After keeping the suspension, it will settle down. Particles will sediment, and that's why it is called as unstable. And in suspension we can see Tindal effect and Brownian movement at last. Now move on to the next. So examples of these are chalk powder in water and mud in water. Move on to the next is colloids. Colloids are also heterogeneous mixtures where the particles are very small. How much small? They are not smaller like solutions, but they are bigger than solution but smaller than suspensions. What is the range of it? Means in solutions the particles are lesser than 1 nanometer. In suspension the particle size is more than 100 nanometer, but in colloids the particle ranges between, size of the particles ranges between 1 nanometer to 100 nanometer. And colloidal solutions, it can also be called as colloidal solutions because it appears like homogeneous, that is solutions, but it is absolutely heterogeneous, and it shows Tindal effect and Brownian movement. In colloidal solutions there are two phases, dispersed phase and dispersion medium. In solution you know that there are two components, one is solute and another one is solvent. Solute means if you take salt and water, salt is very less in amount, water is more in amount, so solute is small amount, that is salt. In the same way, dispersed phase is less in amount and dispersion medium is like solvent, which is more in amount. Now examples of colloids are milk, smoke, gel, blood, ink, paints, butter, ghee, clouds, there are many colloidal solutions you can observe. And moving on to the next concept is Tindal effect. As I told you, Tindal effect can be seen only in colloidal solution. Perfect Tindal effect you can be seen in colloidal solution. You cannot see in solutions. You can see the Tindal effect in suspension, but it is temporary, not permanent. Permanently we can see through colloidal solution. What is Tindal effect then? If you pass a beam of light through the colloidal solution, you can see the path of the light. That path of the light is because the particles which are present in the colloidal solution, they are bigger enough to scatter the beam of light. They are not too much big. They are between 1 nanometer to 100 nanometer. We cannot see the particles also there, but they are bigger enough to scatter a beam of light. The scattering of light is said to be Tindal effect here. And moving on to the next concept is Brownian movement. What is Brownian movement? In the colloidal solutions, again, if you see the particles in the colloidal solution by passing a beam of light, the particles will be moving in the zigzag motion, and this motion or movement of particle is called as Brownian movement. So today we have understood about heterogeneous mixtures, that are solid suspensions and colloids, and also we have understood about Tyndall effect and Brownian movement. Thank you, children.